So we're working our way through talking about classes, objects, and methods. So there's the concept of overloaded methods. So there are method overloads, and then when you get to the idea of inheritance and superclasses and subclasses, there's also method overrides. Those are two different things. And we saw override used when we did a dot equals method. Pretty sure we did that. Yeah, pretty sure. What? Really? Took that long to get to it? No way. Yeah. Way back in slide 13. We created a dot equals. And so we're going to do it again. But what an overloaded method is when you have more than one method that has the same name but different data types. So you could write something that took an int and something that took a string in as the piece of data. And there are times when that's actually useful. Here they have four different methods. Validate using a word, validate using a number, validate using a word then a number, validate using a number and then a word. All right, you have four different methods that are essentially doing the same thing, whatever the validation is supposed to do. So let's create a little bitty example of that where you can create somebody who has only a first name, or somebody who has a first and a middle name or last name, or somebody who has a first, middle, or last name. Right? Three different attributes. So we're going to create a class that has three member variables, instance variables: first name, middle name, last name, F name, M name, and L name for those three things. So I'm going to create a new project. Once it gets going, get rid of the package declaration, move it to its correct folder, move class to correct folder. All right. So now inside projects, I want to create, I don't know what this class is tracking, person, names, new Java class, person. And all we're going to probably wind up tracking is the first and the middle and the last name, but we'll see. So I'm creating a new class called person, and it's got three instance members. If I'm a good programmer, I will make them private because my rules for creating classes include data private, methods public, add constructors if they make the class easier to use, add a tostring method, and add an equals method. So along with your data private, you have to add getters and setters. So this is like, how many rules do we have here? If you count data private, methods public as one rule, one guideline, these aren't rules. Getters and setters is a second rule. Constructors, if they make the class easier to use, is a third. A tostring method, and an equals method if you're ever going to compare two objects. Seems like I skipped something. 4 and 5. Okay. Prof. Thompson's five guidelines for class creation. We're going to do this. Data private and methods public. So private string F name. Let's go ahead and give them default values. Just empty quotes, you know. Private string M name. Private string last name. I'm going to be terribly lazy. We know how to write getters and setters, right? I'm going to do the getter and setter for first name and then let NetBeans write the other two, just to reinforce, make sure we know how to do it. getters and setters need to be public. Public string, because a name is a string. Get fname. Return this dot fname. So this is an accessor. Accessors are getters. Now let's provide a setter for it. Setters don't need to return anything quite often. So public void set fname. And this is a mutator. So I'm adding a comment, mutator, which is a setter. And so this, oops, what am I missing here? If we're going to set the name, don't I have to know what I'm setting it to? Yeah, I do. String fname, or just string s would be enough. And then this dot fname is equal to s, like that. So we've done the first getter and the setter. I'm feeling super lazy. I want to get on to the next thing. How do I add the other getters and setters? Anybody remember? NetBeans can do it automatically for us. We highlight those two variables. Looks like I've got that backwards. In main? No. Middle name. M name. Don't know where I came up with that. All right. So anyways, highlight. Use your cursor, use your mouse or whatever to highlight those two things. Then do refactor, encapsulate fields. And you can see that it's offering now to encapsulate the fields that we highlighted. In this case, it's what it's calling a field. We've been calling an instance variable. They're both correct terminology. It's just that our book doesn't use the term fields. Refactor. Now we have a bunch more methods, right? And it puts them up at the very top. I hate that, so I'm going to take my 3 instance variables, cut them, and move them to the top of the class. So you just have to scroll down, find it, find those variables, push them back up to the top of the class. Now this adds a whole bunch of comments too. So suddenly our class is very long looking, right? It's not super duper great looking, but it does the job. You could always go back and remove those comments if you really hated them. Now let's write some methods. We could set the first and the middle and the last name separately now. But why don't, let's go ahead and prove that. So I'm going to go back to our main method, our client code, what the book at some points calls a driver. So I'm going back to main in the other method, in the other class. I'm going to create a person. Person P1 is equal to new person. That creates a person object. And assign it to the P1 reference variable. That's what that does. Now let's set his first, middle, and last name. P1 dot fname. No, excuse me. P1 dot set fname to Bob. P1 dot set middle name to Q. And P1 dot set last name to Johnson. We have a person there. It would be neat if we could do this. Person P2 is equal to new person. P2 dot set, or set names. I'm just going to call it set for now. Maybe I'll come up with a better name. Bob, comma, Q, comma, Johnson. Right? Wouldn't that be cool? Or what if we didn't know the person's name? Their middle name. P2 dot set Bob, end quote, comma, Johnson. Or what if they're one of those rare individuals like Cher and Bono, who get to be known by only one name. p2.set share. Like that. That would set their first name. We have three methods here with the same name. If we didn't know about overloading, we might do something like this. Now don't type it because I'm just going to do it. But we might do set first, middle, last names, like that. And then we might do set first, last names. And then we might just have set first name, which we already have. You know, we already have the ability to do that. We might write three different methods that do the same thing. You know, and then if we have all three bits of information, we'd call one of those methods and the other. But it's much more awesome if we can just let the programming language figure out which one we want to call based on the parameters that we pass to it. I think instead of just set, I'm going to call it set names, like that. So p2.setNames like that, or p2.setNames like that. And what I did is I copied and I pasted it. And p2.setNames like that. But we got to write the code to support that. So we're going to have to add several versions of the setNames method. One setNames is going to accept 3 strings. One setNames is going to accept 2 strings. And one setNames is going to accept 1 string. So go back to your person class and we're going to add those 3 methods. I'm just going to go down to the bottom. I like to put a comment here to help me keep track of things. At the bottom of my person class, I'm going to put end class, just to keep track of things. You've all gotten in a situation where you don't have enough closing braces or you have too many. So public void set names. Let's just do the first one first. String first. And so we're going to set this dot fname equal to the first. But we're going to write 2 more versions of that. One that takes 2 strings and one that takes 3. Public void set names, string first, string middle, this dot first equals first, or this dot fname is equal to first, this dot mname is equal to middle, and you can already guess what the third one is going to look like. Go ahead and write the third one on your own. I'll wander around and make sure y'all get it. So doing the third one, I could just copy this one, right, and paste and modify. But I'll go ahead and type out the whole thing. Public void set names, string first, string middle, string last, open brace. This dot fname is equal to first, semicolon. This dot mname is equal to middle, semicolon. And this dot last name is equal to the last. So we have 3 different ways of setting the information. You only do overloading if it's actually going to make the program easier to understand or your class easier to use. You don't need to go nuts adding overloads just for kind of theoretical purposes of which you're never going to use. And we're going to overload one more thing. Every person also has an age as well as a name. Actually, we should have a birth date and calculate the age based on that, right? But private int age, going to default to 0. We need getters and setters. I should make them type them in yourself. Public void set age int age in parentheses, this dot age equals age. And we need a getter. Public int get age, parentheses in parentheses, return this dot age. Okay, so all very well and good. After we've created a person, we can set his age. But to set their age, we're forcing the age to be an int. What if the age that they have available to them in the application is a string? You know, we've scraped it from the web, or our input functions only return strings rather than ints. I'm going to go back here. It seems like I have some error going on. No. So Control S on person.java to save it. Control S on Java application. Okay, here's what I'd like to be able to do. Since person2 seems to have so many different names, we're going to give them a couple different ages as well. p2.setAge. They're 30. But p2.setAge with a string like that would be cool, but it's not supported. Our class does not have a version of setAge, does not have an overloaded version of the setAge method that accepts strings. So what is the calling code going to do? The calling code could convert the string to a number and then call setAge, or we can make the setAge method handle a string. That's what we're going to do, just for example. I'm going to go back to the person class, and I'm going to add one more setAge method that accepts a string. Public void setAge string age. We're going to have to parse it, right, with integer.parseInt. So let's just store it in a temporary variable. Int temp is equal to integer.parseInt, capital I, parseInt, lowercase p, capital I, age, and then set this dot age equal to that temp variable. And yeah, we could have done it in one step rather than two. So do you have to overload all your functions to accept strings as well as numbers? No. Only if it's useful. Only do any of this stuff if it's useful. If your code never is going to accept, just first names as well as first and middle and last names, then you don't need to write 3 different, methods for setting the names. Just one would do. Or, one for each field. One thing that is very, very useful, though, is providing parameterized constructors. I'm pretty sure we have done this, but we're going to do it for this one as well. Or at least we're going to go over to our client code and show how we would like for it to work. Person P3 is equal to new person, and their name is Susan, comma, P, comma, Smith, end quote, comma, and she's 25 years old. And then we wouldn't have to call any setters after doing that. So if it's going to make your class easier to use, like that, go ahead and add a custom constructor. Once you add a custom constructor, a parameterized constructor, parameterized because it takes these parameters, you're going to have to go ahead and provide a default constructor. Java gives you the default constructor, which is the one that doesn't accept any, any parameters between, any arguments between the parentheses. But once you put your own constructor in there, you have to go back and add the default. So we're going to, we can prove that. But once we add a parameterized constructor, these other calls are going to fail, the creation of P1 and P2 until we create it. Well, let's do that. Let's add a constructor. A constructor is a method with the same name as the class, which is invoked by the new keyword when the object is being created. It doesn't have a return type. So we're not going to say public space void space person. We're just going to do public person. And I'm going to be, alrighty, string fn for first name, string mn for middle name, string ln for last name, and int age. And we know what to do here, right? This dot fname is equal to fn, that parameter. This dot mn, or mname, is equal to mn. Would it have been better to use the full variable names? Yeah, it would have. This dot lname is equal to ln. This dot age is equal to age. I thought it'd be easier to type if I did that, but then I kept messing it up as I typed it in. So now we have a constructor. If we flip back, once you Control S this code, once you flip back to the driver, you're going to see that your constructors, your calls to your constructors, P1 is equal to new person, and P2 is equal to new person, are now broken. So it's like, great, I fixed this one, but I broke the others. So we're going to go back and fix that. We just have to create a default constructor, even if it doesn't do anything. And the only reason we're having to do this is once you add a parameterized constructor like that, Java removes the default constructor, no longer provides one for you. So let's make a default constructor. That's all it is, and that's all it needs to do. And this is a parameterized constructor because it takes parameters. I also call it a custom constructor because it's not the default. Now if we go back to our application, it works. Right? You can create a person, you can set their names, or you can do it all in one fell swoop. This person up here doesn't have a name, so I'm going to do a p1.setAge as well, just for grants. p1.setAge. I'm adding this to the person 1, and this person's young, they're 21. We have several versions of these things being called, right? Would you really need to call set names 3 different times? Nah, they were just, 3 different examples. Similarly, would you need to call setAge 2 different times? No, that was just 2 different examples. All right, so out of our principles for designing classes, we've done that. Our data is private. We're making our methods public. We have getters and setters, constructors if they make the class easier to use, and I would argue that that is easier than that. But once your class has like 20 different members, instance variables, are you going to make a constructor that takes 20 different parameters? Probably not. So at a certain point, you kind of give up on the idea of a custom constructor. Then a tostring method, and what you use tostring for is to actually print that person out, or at least for debugging purposes. Come down here and do system.out.println P1, and then copy and paste that and make it P2 and P3. System.out.println person 1, person 2, and person 3. Now when we run it, it's not going to print anything useful. It's just going to print the name of the class followed by a hexadecimal number. Not terribly useful. See that? I have 3 persons. 3-person objects, each one of them with a different hexadecimal number. The first part before the @ sign is the name of the class, and the second one is a hash value for where the person object is located in memory. That's not useful at all. It'd be a lot nicer if it actually printed out the person's name, stuff like that when you did that. So let's do that. We're going to go add a tostring method. The syntax has to be very precise. This is called overriding, not overloading. We have overloaded this function, this set names. We provided several different versions of it, wherever that was. Yeah, set names. We provided 3 different versions of the set names method. We provided 2 different versions of the set age, one that took a string and one that took an int. So those are overloads, but now we're going to do an override. Override means replace a method, not add a new one. Replace a method that we inherited from another class. Not that we know what inheritance really is, but every object in Java inherits from something called the object class. And the object class gives some very basic methods, including tostring, which is used to try to print it. But the tostring method that the object class gives us isn't very useful. It doesn't give us much information, so we're going to write our own. Public string, tostring with a capital S, and let's build a string to return. String S is equal to empty quotes, and there's always way more than one way to build a string. So S plus equals their first name plus a space plus their middle name, M name, plus a space plus their last name. Now let's tack their age on it. Plus equals age equals end quote plus their age, like that. And then let's return that string. Now I seem to have a syntax error here. Unexpected type, required variable, found value. Oh, I put an equal sign here. It was supposed to be pluses the whole way across. I hope you typed the plus. If you typed in what I typed, an equal sign, you got to fix that. All right, now when we print it, we're going to see some names and ages. Now when we run it, I mean. There we go. We printed out 3 names. Bob Q. Johnson, age 21. Cher Johnson Johnson, age 30. Susan P. Smith, age 25. Now it could be that when we have our different versions of set names, that we should have blanked the other ones out, right? If we just passed in Cher as a first name, maybe we should have blotted out the middle and the last names. So if we can find them, let's go back to our set names methods and do that. So just do a Control F in your person class, Control F, and look for set names. That'll jump us down to where they are. And so for the one that accepts only one parameter, let's set the middle and the last name to blanks. This.mName is equal to a blank. This.lastName is equal to a blank. Do that for the one that takes 2 versions, 2 variables. So it's already got first name and middle name, so let's just set this dot lName equal to blank, empty string, double quotes. And the third one takes all 3 values, so there's no change to make. So when we run it, there we go. Bob Q. Johnson, age 21. Cher's 30, yeah, right, and Susan P. Smith is 25. Now this looks a little bit weird because it's got some, blanks in it, but who cares? This is just for demonstration purposes. We could check to make sure that they don't have a last name, or if they do, and if they don't, then don't put the space in front of it, that kind of stuff. But that's what tostring does, because when you print something, like we did here, print is accepting a string. And if what you give it is not a string, it calls tostring on it. And so automatically, that tostring method is invoked. If you didn't trust it, you could call it by hand. You could type in P1 or print line P1 dot tostring, parentheses in parentheses. But you don't have to, because it's already invoked by default just because you tried to use it as a string. And then the dot equals method so that you could check to see if two people were the same. We're going to go ahead and do that so that we have done all 5 of my guidelines for writing classes. Now, do you always have to implement dot equals? Nah. Do you always have to add toString? I think it's really useful for debugging purposes, but the user probably isn't going to see it in that format, so it's not a must, but these are guidelines. So let's go back. Are we all good, or do we have no typos?
On person?
Yeah.
That, I mean, error doesn't really matter, right? Because it runs smoothly, but why, I mean, is that something we have to even know about? If you go back to click the person, and then scroll up back to line 15 around there, where you have it. See that little, wait, go up one more. It's right under 8. It just says 2.
Oh, it's giving you a warning. That's right. I forgot to mention that. NetBeans wants you to do something additional to your toString method. As I mentioned, this is what's known as an override. And check out the little warning. If we click it, it says add the override annotation. You may as well go ahead and do that. It doesn't change the way your code works. But if you made a mistake, like now I'm going to try to create an equals method, but I'm going to make a mistake in it. And I'm going to add that tag first. Override public Boolean equals, and I'm going to think mistakenly, but it's a very reasonable assumption that it takes another person as its parameter. And it's going to return a true. We'll fix it so that it actually returns something better than that. Right now I'm just demonstrating what the override keyword does. It yells at us. It says, this isn't really an override. It doesn't implement a method from the supertype. And you're going, but I meant it to. Equals is supposed to be an override, just like string. And then you look up the syntax for the equals method, and what it does is it doesn't take a person. It takes just a generic object that I mentioned. So I changed that word person in my method to object. That makes the error go away. It's showing a little warning here. Then I'm going to click it just to see what it does. Why'd you do that? Alright. I'm going to undo that. Okay. So how do we know if two things equal? If all of their fields match. But we have to convert this other into a person reference. So person P2 is equal to parentheses person in parentheses other. That's known as casting. We're taking this other object, we're hoping it's a person, and so we're converting it to a person reference. Why? So that we can reference all the methods, all the member variables, instance variables. So now, if this dot fname not equal to person2 dot fname, I want to rewrite my stuff a little bit. Sorry, I'm going to delete that line. Where it says object other, just make that object O. And this line, instead of person P2 is equal to person other, make it person other equals parentheses person with a capital P O. And that way when we start writing these if statements, we can do this. If parentheses this dot first name is not equal to other dot first name, return false. And do that for all the other members, M name, L name, and age. The if statement is redundant. I don't care if you think it's redundant. If this dot mname is not equal to other dot mname, return false. If this dot lname not equal other dot lname, return false. And then their ages. If this dot age is not equal to the other dot age, return false. And if none of those caught a problem, then return a true. So if we can't prove them guilty, if we can't prove them to be different, they have to be equal to each other. Equal meaning they have the same first, middle, last names and ages. I made a terrible mistake. I think I'd already lectured about how you can't use equal to compare strings, right? And now I'm using equal or not equal to compare strings. This syntax is wrong. We could let it fix it automatically by clicking on these things, these little warnings. Use dot equals like that. The last one I'm not getting. The if statement is redundant. Says who? No. Undo that. All right. So that's a lot of typing, but it's pretty understandable. If this object's fname dot equals the other object's fname, but then we put a not in front of it, then return false. And so by letting NetBeans do that, I saved a little bit of typing, but I didn't mean for that to happen. And remember, you don't need the this reference if there's no chance for confusion. I don't have an fname variable anywhere else in here that's not referenced like by others, so I could delete those this references. But I like the syntax of this equals other. But I could have done it like this: if fname dot equals the other fname, and if mname dot equals the other thing's mname. So it's up to you whether you like the this keyword, and I really do. All right, now we got to go in and actually utilize that stuff. Are we all done typing? Okay, so go back here. Let's make two people who are identical. Let's make a new person who is identical to Susan Smith. Person P4 is equal to new person. I should have just copied and pasted the line, right? Susan, end quote, comma, P, end quote, comma, Smith, end quote, comma, 25. I'm just creating a variable called match. And so Boolean match is equal to P3 dot equals P4. And then we're going to print out something. System.out.println P3 equal P or P3 equals P4 question mark, followed by that match value, like that. Now change the age of one of them, either P3 or P4. And then do that comparison again. So person 4 dot set age, she just aged 25 years. Now do the same thing. You could just copy and paste this code, but so match is equal to P3 dot equals P4, into parentheses, semicolon, then the same print statement. System.out.println P3 equals P4 question mark, end quote, plus that Boolean variable match. So hopefully, the first time it prints this, it's going to say true. Because unless I've made any typos, these objects are designed to be the same. Same values, not the same object. But then we change the age of one of them. They no longer have equal values. And so when we call dot equals, it ought to say false. All right. So the first time we ran it, P3 does equal P4. That's true. You could write an if statement that does something based on that information. Or P3 is equal to P4 false. All right, so we have written a class. We have demonstrated overloading. We have demonstrated overriding. We used overriding to add a dot equals and a tostring method. We're not going to do anything else with overriding this semester. Once you get to Java 2 and we start doing inheritance, you'll use a lot more of that. Constructors, we've already talked about them, but now the PowerPoint's going to talk about them. Up to this point, we have used mutators to assign values to the instance variables, which works okay, but it requires calling one mutator for each instance variable. It's cooler if you can do it all at one time. Well, here they show using an alternate method that accepts 3 variables. That's just like our set names that took a first, middle, and a last name. It's a pretty good solution, but it still required 2 things. We had to create our car, and then we had to call the setter that set the 3 values all at once. It works, but it'd be even niftier if we could just do Ashley car is equal to new car and then pass in all of those parameters at the same time, like that. You know, I'm sure that's messed up all this. Like that. That'd be cooler. And by cooler, I mean I would hope that it would make writing the code easier. So constructor lets you specify what happens to an object when it is instantiated by the new keyword. It's called automatically. You don't have to call it. It just gets called automatically. The constructor's name must be the same as the class name, and don't put a return on it. Constructors don't return anything. We can verify that if you went to our person constructors. There's no return statement on them. So here, they're going to make their car class have a constructor that takes the model, the year, and the color. Just like we did. So anytime you instantiate an object with new, there must be a matching constructor. The number and the types of arguments in your constructor call must match the numbers and types of the parameters in your defined constructor. In one of your defined constructors, because you can write a whole bunch of different constructors if you want. We wrote 2. So if we call our constructor with no parameters, then it would invoke the default constructor. And we did that in a couple of places. In our code, you know, when we created person 1, we didn't pass in any parameters. We didn't pass in any arguments. So that was hooked up to this constructor with no parameters. Later on, we called our nice nifty parameterized constructor that does accept arguments. And so it looks for the constructor that has a string, 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 integer. We scroll up in our person class and we do find that we provided a constructor that takes a string, 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 integer. So they have to match. And if they don't, like if for some reason we forgot to put the age variable in, then all of a sudden, all of our code over here that depended upon that constructor no longer works. So I'm going to undo that change. Go back to the person class, undo until I get my age parameter back. So overloading. Overloading occurs when there are 2 or more constructors. They can have the same name but different parameters. To call an overloaded constructor, use this syntax. Oh, We're not going to even talk about that. That's for object-oriented programming. Not object-oriented programming, for using inheritance, which we're not talking about. So sometimes you'll want an object's attribute to be fixed or constant. To make it constant, use the final modifier. Although a person can change his or her name, usually a person's name is constant, so it's fairly common to use final for a person's name attribute. For example, public final string name. When you use a final for a variable declared at the top of the class, you're creating an instance of a named constant. This isn't really grabbing me. Let's go ahead and provide a class that demonstrates having constant instance members, constant instance variables. So go back to your class, go to your projects. In the same folder as your Java application in your person class, let's just do a point that has an X and a Y. So new Java class, call it point with a capital P. And we're going to do a final int X, a final int Y, a final int Z, and we need a constructor that'll assign values. So we're going to make a constructor. Public point, parentheses, int X, comma, int Y, comma, int Z. This dot X equals X. This dot Y is equal to the Y parameter. This dot Z is equal to the Z parameter. Now those values can never change. Even if they're public, they can never change. They are constants now that they have values assigned to them. If you try to write setters, you're going to get a syntax error. Let's just prove that. I'm going to write a setter for set X. Public void set X, parentheses, int X, and I don't care if you do this or not because it's going to be a syntax error. This dot X is equal to X. Can't do it. We can't change the value of this point of the any of the instance variables of this point because they have been declared as constants. These are their final values. They're not allowed to change. I can't think of a super compelling reason. I don't really do that very often at all, or have I ever in my professional programming. So, but that's the way it works. Use the final keyword, you make a constructor that'll set them, and after that they're never going to change. You still probably want to give getters for them unless you just, yeah. I ought to provide a get X and a get Y and a get Z method. But since this was just a sample, I'm not going to. Let's go back to our client code and create a point just to prove that we can. So I'm going to go back to main in my client code and do point. I can't use P1 because that was already for, So how about X1 is equal to new point 10, 20, 30. And then int X value is equal to X1 dot X. Int Y value is equal to X1 dot Y. Int Z value is equal to X1 dot Z. But let's try to change one of those. X1 dot X is equal to 100. That's an error because X, Y, and Z are all constants. So to follow strict programming principles, I should have provided a get X and a get Y and a get Z and use those instead. But honestly, if I do have final, if I do have constants, I don't mind referencing them just like that. Just like math.pi, right? You don't say math.getPi. Pi is a constant, so you just reference it as math.pi, right? So my rule of thumb is that if a variable is a constant, I don't provide a getter for it. I just let them have access directly to it. So I can make them public rather than private. It's kind of an exception to the rule. Nothing else to do with that, so I'm not going to bother doing anything else with that for now. So instance constants, that's still what we're talking about. It is legal to assign a value to an instant constant only one time, so in a constructor. If you attempt to reassign an instance variable at any other place, the compiler generates an error. So because the final modifier keeps a named constant from being changed after it's initialized, it's safe to make it public. Just like I said, so that I can access them as .x, .y, and .z rather than .getX, .getY, and .getZ. So based on what you've learned so far, when you're working on an object-oriented programmer, you should envision separate objects, each with their own set of data and behaviors. The data are the instance variables, and the behaviors are the instance methods. You have a circle class, its data is the radius. And the instance methods, the behaviors, are get surface, get area, or get circumference. That's a valid picture, but you should be aware that in addition to datas and behaviors, you can also have datas and behaviors that relate to the entire class. Since they relate to an entire class, they are known as class variables and class methods. We will give one example of that. I'm not sure why, but let's keep track of how many person objects have been created. We're going to create a class variable. So go back to our person class, and a class variable is one that has been defined as static. I'm going to declare it as public. Know that you should make your data private, but I'm just going to declare this as public. So public int num people. Starts off as 0, right? Because we haven't created, but I need to declare this as static because it's going to apply to the entire class. It's not like each person's going to have a different number of people that have been created. We just want to keep track of the total number of people that have been created. So public static int num people is equal to 0. Now we need to go find our constructors, and each time a person is constructed, we're going to increment that variable by 1. So public static int num people is equal to 0. Scroll down until you find one of our constructors, and we have 2 of them. There's one. The person, public person, right there. We could have just done Control F and looked for public person. When we call that constructor, we're going to add 1 to the number of objects, but you can't use the this keyword. That was my mistake. So num people plus plus. Do that to the default constructor too, a little bit further down in the code. Since I wrote it like this with no space between the braces, I'm going to have to actually add some space now so that I can then do num people plus plus there as well. So now I'm going to go back to the main, the driver class, the client code. And each time I create a person, I'm going to print out the number of people we have created. System.out.println people created equals, end quote, plus person.numPeople. And then I'm just going to copy that code so that I can paste it after every time we create a new person. So after I make person 2, I'm going to print that information out again. Then I'm going to scroll down here, and after we make person 3, I'm going to print it out again. I'm going to do the same thing after we make person 4. Now as we watch it, that number will increment. 1, 2, 3, 4. Here we go. Number of people created 1, 2, 3, and 4. Notice that when we access that variable, we do it with the name of the class, not the name of an instance. We don't say p1.numPeople. We could try it. Let's see if that works. I'm going to go down to the bottom of the code and do system.out.println people created is equal to p1.numPeople. It gives us a warning. It's not an error to do it this way, but it's going to say you're accessing a static field. Replace it with a class reference. Why? Because since this is a static variable, p1.numPeople is equal to p2.numPeople is equal to p3 is equal to p4. It's all pointing to the same thing. And that's a weird concept. But it's a class variable, not an instance variable. Instance variables differ on an instance by instance basis, but a class variable is the same. And here's my dumb example of that. Say that you have a whole bunch of different blueprints. And all the blueprints have different data on them. You know, this house takes 4 doors, and this house has 2 bathrooms, while this one has 3. But they all have the same architect name. So architect for that set of blueprints could be a class variable, because every blueprint has the same architect's name. Now that's kind of a silly assumption, right? But all of those blueprints have one shared common attribute, the architect's name. Maybe they all have another shared attribute, the color of the blueprint. You know, they're all blue. That kind of thing. I never really wound up using class variables a lot in my professional programming, unless I was in something. Nope. Here, you know, all the methods are static, so if we wanted to add any class, if we wanted to add any variables to our client app, we would have to make them static as well. Like, what if you wanted to read in input using the scanner class, but you wanted that to be able to be accessed by any method within the main class, the client class, then you could declare that variable as being a class member. So public static scanner sc is equal to new scanner system.in, and now I could use that scanner inside every single method inside my main class, right? I'm going to delete that, but that's about the only use I ever found for class members. That doesn't mean that's the only use for them, but it's the only one that I found is when I was in my main application, and since everything is already defined as static in there anyways, if I wanted some data to be shared by the methods in the main class, then I made those variables static as well. All right, that's about enough of that. I think we actually got pretty close to the end of this chapter, although it doesn't look like it, but we did. We've talked about scope before, right? I've used the word scope and talked about the scope. Yeah, it's just the area where the variable is accessible. Local variables are only accessible within their little, curly braces in which they're defined. This thing says to make constants class members, and that makes sense. The value of pi is not going to differ on an item by item basis, so define pi as a constant, but as also a static member, so that you can access it without creating a new object. You don't have to make a new math class just to get the value of pi out. Okay, we are done with that chapter. Do read it, but we are done with it.